So as we go into the home stretch and we talk about putting it all together for programming, I wanted to have us write a program together that exercises a lot of what we learned throughout this video series. And so I want to kind of walk you real quick through the process that I went through to kind of figure out what I wanted to write. I wanted to write a game of some kind because I wanted it to be fun, but I wanted to make sure it wasn't going to be too complex and it wasn't going to be too easy, right? So if we did like a simple like flip a coin game, that wouldn't be very fun. It's too simple. Something like where we both throw a six-sided die and the one who has the highest number wins. That's still kind of boring. But it turns out if we do card games like poker or even solitaire, that ends up having a lot of different game rules in it, and it winds up being very complicated very quickly. So I found a game that I think is a good balance between simple and complex. At the same time, it's also a fun game. And that's a game called Senet. Senet. And Senet is an old game. It's an old board game, dates back to ancient Egypt. And I learned about this, I don't know, some years back, and kind of been infatuated ever since. What's interesting to me is that because it's such an old game and nobody seems to have written down the rules in a way that modern archaeologists have discovered, nobody really knows how to play the game. There's some evidence you can put together to figure out how the game might have been played, but there's some disagreement over certain rules. That gives me a little bit of flexibility. There's two different popular rule sets. I use a variation of one of them, which I'm going to show you right now. Now, I've got a board here. Let me show you what the board looks like. So this is a Senet board. And the Senet board, as you can see, has these 30 squares that are set up in 3 rows of 10. And there are certain squares that have an important value. And so over here towards the end, the very last square, typically that's the square where you need to throw a 1 to get off the board, because you eventually need to get your pieces all off the board. Here is a square that has a symbol with like a 2 on it, and so you need to throw a 2 to get off of that to get off the board. You can't throw like a 1. This one has a sort of a 3 marker on it, so you need to throw a 3 to get off the board. You can't throw a 2 or a 1. This isn't a 4 square. This actually ends up being a trap square of some kind. So actually, if you land on that square, you're supposed to resurrect up in this square up here. Now there's certain game disagreements, rules disagreements around what happens if somebody's sitting on that square. I tend to go with a very simple rule set where if somebody's on that square, you can't make that move. And then this square, you have to stop exactly on this square before you're allowed to progress to the rest of the board. So the game can be played with a lot of basically a mixture of luck and strategy. You start the game by, you have these 2 different game pieces. So you've got, it could be different colored pieces, or it could be different shape pieces. This is one different color and different shapes. And you start the game by, and so actually the game, by the way, is played in sort of a backwards S configuration, which is kind of weird. So if you imagine if you start up here, you're going to go all the way to the right. You're going to go down a row. And then you're going to go all the way to the left, and you go down a row, and you go all the way to the right. That's how game style moves on this one. And you start the game by alternating at this top row. Each player has 5 pieces, and you alternate it, placing player 1 and player 2 pieces on the board. So each one has 5 pieces. You're alternating them, so that takes up the entire first row. And then you, to make your move, you throw these little throwing sticks, which I've got right here. And so these throwing sticks they're split in half. So when you throw them, you sort of jumble them up and you throw them on the ground. And then it's the number of sticks that have white showing. So you throw these 4 sticks, and so it's the number of white sides that you end up seeing. So here I'm showing 2 white sides, and so you have a move of 2. Again, there's some disagreement around what happens if you have none, if they're all black. Some people say, well, then you move 5. I like to play the very, very simple route where you throw the throwing sticks, and if it's the number of white sides that you see. And so if they're all black, If it looks like that, then you have no whites, which means you lose a turn. So again, I'd like to kind of have a very simple version of the Senet game, which for me is a fun game to play. And so let's write a simple version of Senet. Now, I'm going to bring up a new file. So we'll do Senet.c. Now I need to think a little bit here about how I'm going to write this program. You know, what functions do I need before I'm able to write my program? If I'm going to, sort of get started, the outline of the program I think might look like this. So include, let's just do a standard IO because I'm going to print out some stuff, and then my main function. So I'm going to need to have a board that is 30 squares wide. So I'm going to need an array called board that is 30 squares. And let's just do an int here. And if I were going to do, what am I going to store in that array? So that array is going to represent the 30 different squares. We'll figure out a way to make it actually appear to move in that backwards S. But just to kind of look at what's in there, I'm going to store values of 1 or 2 to indicate if it's player 1 or player 2, or 0 if nothing's, if there's no piece that's on that square. So if I were going to try and populate this array right away, I might do a for I equals, let's use a better variable name here. We'll call it square for SQ. For square equals 0 for as long as square is less than 30, which means I'm going from 0 to 29, and we'll do square plus plus. Then I might say board at that square position is 0. And then to populate the first row, I would say for square equals 0, and as long as square is less than 10, right, because 0 through 9 is the first row, that's the first 10, and then square plus equals 2. So I'm going to advance that by 2. Remember, that's shorthand. That's the same as saying square equals square plus 2. But I'm just writing the shorthand here of square plus equals 2. And oops, why am I doing that? I'm doing that because I can say board at whatever square position. So that's 0, 2, 4, 6, 8, but not 10 because it has to be less than 10. That's going to be player 1, and then board at position square plus 1 is going to be player 2. So that's going to be automatically, it's going to be 1, 3, 5, 7, and 9, but not 11 because square never gets to, SQ never gets to 10. And if I'm going to try and print out that board, so I'm just going to print out the board here. This is just a demo, just to show it off. For square equals 0, and square is less than 30, square plus plus. I'm going to do a printf of a digit that's in there, and then a space, and that'll be the value of that position on the board. So what is this going to do? This is going to generate a board that in this case is a single line. It's going to be just, I might as well put in, by the way, a new line at the end of that. That's going to print out a single line of 30 squares, and it's going to give either 1, 2, or 0 to basically set up my board. This is kind of what I just want to show you kind of where I'm starting from is my idea. So let's go ahead and set up our environment because I don't think I've set that up here yet. So devel ow set env. Now I can do the Watcom compiler and linker on senet.c. And now I've got a Senet program, and you can see that I've now created 30 squares where the first 10 squares are alternating between 1 and 2. And so this is basically how I'm going to be passing data around. I'm going to be with the assumption that I've got an array that is 30 elements long. Now I might do maybe a better job on that by rather than putting that information on what's called the heap, where I'm creating an array of a static size. I might do a malloc to allocate 30 ints. But for right now, I'll leave it the way it is. So what other functions will I need to actually make this program do its job? Eventually, I'm going to be printing my board in a different way. So let's get rid of that, which, by the way, means I no longer need the include standard IO. I now need to include the con IO and the graph.h. Graph will do the colors. So I'm going to need some functions here. I'm going to need a function that will draw a square. So I'll need an int draw square. Oops. Draw square on. I need to pass it the array. But I'm also need to pass it what square I want to do. So the integer of a square value, and then the pointer to the board. And before I get there, though, I probably will need to have, I know as I think about how I'm going to draw it, think about how I was doing some of the other sample programs in the previous weeks. I started out with I'm going to start out with another function that's just going to set a square. Basically, as I draw each square, it's going to be much easier if I can actually define the text window, and that's what I'm going to define up here. I'll have one here called set square. That's just whatever square I'm going to give it. Let's write that function first. So I'm going to need to have some coordinates here of a row and a column. And let's remind ourselves here what the board's going to look like. In terms of the array always starting from 0, I'm going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That'll be the first row, because that's now 10 cells. But then it goes backward S. So if I go down to the next row, the 10 position will be on the right-hand side, and then to the left of that will be 11, and then 12. So I'm counting down basically from 19, 18, 17, 16, 15, 14, 13, 12, 11, and 10. And then once, because it's backwards S, once I hit 19, the next one from there is 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. So that's my 30 squares on the board are going to be represented that way on the screen. So I need to do a little bit of like smart math here to figure out where I'm going to position each square in the screen. So that's why I'm putting it in the separate function. So that way, the funky math that has to figure out where the coordinates are for each square window, where they're located. It's in its own little function. So if I need 10 squares on each row, and I've got 80 columns on my screen, well, that's easy math. That means that I need to have each one be 8. But if I want to have like a line or like a column, a blank column between each square, then that means each square squares they'll need to be 7 screen columns wide plus an extra square, right? So blank square. And so that means that it's going to be at every 8. So it's going to go things like 1, 9, 17, right? That's what the coordinates are going to look like. They're going to have to go on those screen columns, column 1, column 9, column 17. So that's what we're going to have to end up with. So let's go ahead and figure out what that looks like. So the middle row has to count backwards. So let's tackle that one first. So if I'm looking at the square is greater than or equal to 10, and the square is less than or equal to 19, then that means I'm on the middle row. And so that means it counts backwards. So my column needs to be, counting backwards means it's 19 minus the square. Oops, minus the square. Because that means I want to basically get it down to where it's going to be counting up from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so 19 minus 3, I'm sorry, 19 minus 13 will give me 6, right? 19 minus 12 will give me 7. So I'm doing this 19 minus the square will give me a number that's going to count up from 0 to 9. And each, they're going to need to start 8 screen columns apart, so I need to multiply that times 8. And so now that gives me things like 0, and 8, and 16, which means at the end I need to add 1. And now I'll get numbers like 1, 9, 17. So that's my funky math for figuring out the middle row. And so if it's not that middle row, if it's an else, that means it's going to be the top row or the bottom row. And I could do a separate if statement, else if for the top row, and another else if, or just an else, assuming it's the bottom row. But since all it's going to end up doing is subtracting 20, I can actually figure that out right here. So column equals. So if it was the top row, I'm sorry, if it was the bottom row, I'm going to need to do square minus 20, right? Because then square 25 would get me 5. Square 23, oops, 23 give me 3. So I need to do square minus 20, and that will give me coordinates or column indicators like 0, 1, 2. That's if it's the bottom row. And if it's the top row, and so I need to have that, by the way, in brackets. And if it's the top row, it's just square. So how do I do that? Well, this is kind of calling for an inline if statement. So I could say square is greater than 19. Greater than or equal to 20, maybe. Well, I can't type. Greater than or equal to 20. Then square minus 20. Otherwise, it's going to be square. Right? So there's my shorthand if statement. Inside these brackets, it's going to insert a value. Depending if its square is greater than or equal to 20, that means it's the bottom row. Then it's going to be square minus 20. It's going to insert that value. And if it's not, well, that implies it's going to be the top row, and it'll just insert square. And just like I did up above when I was doing the other multiplication, I need to multiply times 8, and I need to add 1. And that will give me numbers that are going to be like 1, 9, and 17. So now I've got my column calculation out of the way. Let's look at my how tall they need to be. What are my row coordinates? So the squares are how big they need to be. So I did a little bit of math before I did this program. So if I look at something that's going to be squares are 7 screen columns wide, because that lets me take the most advantage of the screen, to end up with squares that are about equal. I'm not going to be perfect with squares that are 7 wide, but I can make squares that are then 4 rows high, and plus an extra blank row. Just to make this comment make more sense, that's a blank column. So how do I do that math? So that math is turns out much easier, because I just have row is going to be basically square divided by 10. So let's think about that. That means that if the square is, let's say, 23, divide by 10, it's going to give me an integer. So that means it's going to be 2. If it's 16, then square divided by 10 would be normally 1.6, but it's an integer, so I get 1. And then 3 divided by 10, you get 0 as an integer. So I'm getting out of this 0, 1, and 2. And just like I did up above, if I need to have them be a total of 5 rows, which means 4 rows high for the square itself, and then an extra blank row, I need to multiply times 5, and then I need to offset it by the appropriate amount. So I need to make sure that the screen coordinate starts at 1. And if I wanted to make room for like a header or something, I might make it start in row 3, so I can do that. And then now I can go ahead and define my text window. So I can define my text window for the square. Oops. Window for the square. And how do I do that? Now I've done all that math. Now I just need to call set text window, starting at row and column, and going to row plus 3, right? Because it's 4 rows high, starting at 1. So I need that to be row 1, row 2, row 3, row 4. So if it starts at row 1, then it needs to be plus 3. So that way it ends up at row 4. And then for the same reason, it's going to be column plus 6. And that should be the end of my function. So now I've got a function that actually defines the text window for the square, and that makes it really easy to draw the square. So when I draw the square, the easiest thing I can do is actually, now that I think about it, I don't need to actually pass the board, because all I'm doing is I'm actually just saying, give me the just draw the square, and I've got the screen coordinates I can figure it out above. But I do want to have a second option though, and that is as I select a square later on, I need to figure out if it's going to be the active square, basically the selected square, the highlighted square. So I might say if this is an active square or a highlighted square. So let's go ahead and right away we can instantly call set square, because we know that we can define the text window. So we can set the square for the square. Now I can go ahead and set the color of the square, because remember, when you do a clear screen on just the text window, it'll use the background color that I've set. So if I'm an active square, then I want to set my background color to be, what do I want to use? Let's use blue for the foreground, for like a normal square, because I kind of like having blue background with a white text. So if a highlighted square, let's use cyan. So cyan, if you remember our color numbers, that's 3. That's cyan. And if it's not the active one, else, we're going to set the background color to be blue. And if you remember the color numbers, that's 1. That's a normal blue. And now I can go ahead and clear the screen. Now that I've set my background color and I've set the text window got set with set square, I can now set the G window when clearing the screen, and that will now clear the screen with my background color. Now I also need to, remember on the Senet board, we had certain squares that had some special significance. So I probably would want to draw some stuff in there. So let's draw some markers on the special squares. So we'll just say here, draw special markers on special squares. I'll probably want to set a text color. Rather than have another if block down there, let's go ahead and set that up here. So we'll do, oops, that should be an underscore set. I need to have a set text color. And what color do I want to have if it's cyan? Or what color do I want to have if it's blue? Well, let's go with the text color being the bright version of that. So what was the bright version of cyan? That was color number 11. That's bright cyan. And then if it was the regular square, then I'm going to set the text color of bright blue. Bright blue, if you remember that number, that was color 9. So that's bright blue. And okay, so now I've set my text color as well. Text color has no impact on clearing the screen for the text window. That's only using the background color. So down here, though, I'm going to set my special square. So let's go ahead and do a switch statement on my square value. And that means I need to have some case evaluations here. So let's remind ourselves. Let's go grab that definition comment, and we'll just move it down here so I have something to remind ourselves what we're doing. Oops, there it is. And paste. So the last square on the board is board 29, and I said that should have a be able to go. You need to throw exactly a 1 to get off there. So 29. Let's put a marker on there. And so what kind of marker am I going to put on there? I want to put a marker that kind of indicates a 1. So let's go ahead and set a text position on row 1. So we'll put it at the top of the square. And then if it's 7 columns wide, 1, 2, 3, 4, 5, 6, 7, the middle point of that very conveniently is going to be column 4, so that's what I'll put in over here. Set text position of 1, 4, and so whatever my text window is, it's going to be the first row of that text window, and then column 4. And let's go ahead and put a marker. So we're going to do out text. And what kind of marker we're going to do? Well, we could do some extended characters, but let's just keep it simple. And I'll make a simple marker. I could do 1, 2, and 3. Let's just do a slash. There we go. Let's do a slash. And then break. And then case, what's the square before it? That requires a throw of exactly a 2. So we'll put some sort of a 2 marker on there. Set text position. I'm going to put a couple of markers on there. What I'm going to put on there, let's figure out what I'm going to put on there first. Out text is going to be slash with a space in between. That'll indicate it's a 2. So what does that need to be? So it's going to be starting on line 1, 1, 2, 3, 4, 5, 6, 7. So if this was the center square, I want to put it on 3 and 5. So I want to set my text position at 1, 3. Because that'll be the center at 4, and that'll be at 3, and that'll be at 5. Break, and then case 27, so the one before it, set text position. You can kind of see where this is going, 1, 2, and then we're going to do out text of slash. All right, so what were some of the other ones that I had? Before that, I had case 26. And remember, that was the one that was the trap square. So that's a trap square. Let's just put a row of something on top of that, across the entire thing. So we'll set our text position. We won't be clever on this one. We'll start all the way up the left-hand side. And we're going to do an out text of 7 characters. What do we want to do to indicate this is a trap? Well, the actual board itself has little wavy lines. So let's do this. Let's just do 1, 2, 3, 4, 5, 6, 7. So that'll be little tildes. And the resurrection square that went along with it. Well, before we do resurrection square, it's right above the stop here square. Stop here square is 25. That's the stop here square. Again, we'll just put something all the way up on top. So we'll do set text position 1, 1. What I'll put up there, we'll do out text of, oh, what do I want to use? Let's use periods. 1, 2, 3, 4, 5, 6, 7. And then break. And then above the stop here square, if the stop here square was 25, there's 25, and above that is 14. So case 14 is the resurrection square. And we're going to do set text position 1, 1, and we're going to output out text. We're going to put up there. Let's put I don't know, just it can be any kind of character. So I'll put backticks. 1, 2, 3, 4, 5, 6, 7. I could use any other kind of marker. I'm just going to use that one. And then do I need a break on the end? Actually, I don't need to have any other special squares. So I don't think I need to have anything else there. And then I could do some other stuff down here if I wanted to have any other kind of markings on the squares. And I think I can probably skip that on this point. Now that I've drawn the square, so I think that's everything on the square. So what have I done up here? I've done in draw square, I've called set square to define a text window. And I've set my color. Most importantly, background color, because that gets used when I clear the screen. But the foreground color, the text color, got set as well. So that way down here, I can, for each square, I can print out certain text, sort of as markers or indicators, to highlight what those squares are. And so I can have another function. That one also be a void. Was my other one a void? What am I returning on that one? Nothing. So actually that can be a void as well. Another function of void, that was a void. I could do I need to have another function here to actually draw my character piece, right? What's my player piece look like? So we're going to have a function called draw player. And that's going to be, well, what square is going to be on, and then what player number is it, right? It's going to be 0, 1, and 2. And so there's my function. What am I going to do? All right, so let's go ahead and set our text window. So we're going to set the square. Oops, I don't need to underscore. Set square on whatever square I'm on. So that defines my text window. Does a lot of shorthand for me. Let's go ahead and set the text position at, I need this to be roughly in the middle. So if I've got 7 columns, I know I need to be at column 4 to be in the middle. These are going to be squares that are 4 squares tall. The first 4 lines tall. The first line has markers on it, so I want to put it in the middle of the bottom 3. So 1, 2, 3. I need to have this on row 3. And probably should set the color, so that way I always make sure I know what color I'm on. So text color is going to be, let's use a bright white. So that's bright white. And now let's go ahead and put our marker on the screen. So what am I gonna print? I could do this in different ways, but let's go ahead and do let's do a switch statement. Switch on the player. So if it's a oops, I'd like to have my cases lined up over here. So if it's player 2, I'm going to just print a do an out text of what am I going to print out? Player 2 is sort of a B. Let's not get too fancy here with different types of of symbols. Let's do like a capital A for player 1 and a lowercase b for player 2. That'll be kind of obvious without being too fancy here. So player, here, let's just do it this way. Case 1 for player 1, and we're going to print a capital A. That's my break. And for player 2, we'll do an out text of a lowercase b. Why am I doing capital A and lowercase b? I'm just trying to make them distinct, right? If I had an A and a B, they're kind of a little tough to read next to each other. If I had a lowercase a and a lowercase b, they're also kind of a little tough to see from each other. But a capital A and a lowercase b, that looks okay. I could also do a lowercase a and a capital B, but to me, I think capital A, lower b looks better. So we'll go with that. And there's my break statement. You know what? I kind of like to have. It's not necessary, but gosh, what if I just want to wipe out the player character piece on the square without having to redraw the entire square? I could do that. So if it's a default, so if it's any other value, it could be a 0, but probably any other value, I'm going to output just a space. And that's the last one, so I don't need to have a break. And so that's drawing the character, or sort of the player's piece on a particular square. Because what I've done is set the square. Now that may have already been done for me if I'm doing this, if I guarantee that I'm always going to be calling this right after I draw the square itself. But maybe I'm not. So we'll set the square. And let's see how this is looking so far. So I've up here already zeroed out the board and then filled the first row. And so let's go ahead and print out the board. So for square equals 0, square is less than 30, and square plus plus. And now I'm going to draw the square for square. And I'm going to, and was that active or not? I'm not active yet, so we'll make it a 0. And then we'll draw the player. And we'll do whatever square I'm on, and then we'll do, well, the board array already has 0s, 1s, and 2s on it, so we'll just call that board square. And so that should print out my entire board. Before I return back to the operating system, let's go ahead and just get a single character before I return. And I probably should, if I'm going to be doing things with the screen, before I get too excited, I probably should make sure I'm in the right mode. So before I do anything up here, let's go ahead and set my video mode to text color 80. Probably should have some code in there to, what if that didn't work? But for this demo program, I'm just going to make that safe assumption. Let's turn off the cursor. And if you remember looking at the C programming function in Watcom, Open Watcom, to turn off the cursor so we don't have the blinking cursor, it's display cursor with the argument of G cursor off. And then when all that's done, before I exit back the operating system, I should probably turn the cursor back on. So display cursor, and that's going to be G cursor on. And then I want to set the video mode back. And so the video mode is going to be the display, set video mode. And if you remember that constant value that I need to pass it is underscore default mode. And then it should be safe to return back to the operating system. Let's go ahead and compile that real quick and just see if we're on the right track. So compile our senet.c, senet.c. And no prototype found for function out text. Oh, that's misspelled on line 60. So let's go ahead and edit Senet.c, and we'll jump down to line 60. And there it is, line 60, and definitely it's misspelled. I forgot a T. Let's go ahead and, was there anything else in that? I probably should have checked if there were any other errors or warnings. No new line at the end of the file, and that's okay. So now I can run my program, Senet. And there we go. I've now defined a very simple playing board. I don't have a background color for the screen. We can add that. But I've got my squares in the right spots on the screen. I'm alternating player A and B, or player 1 and 2, with my pieces. And I've got my markers to indicate the very last square, array 30 or square number 30 on a regular board is a 1. Before that is a 2. Before that's a 3. Before that is the trap square. And before that trap square is the stop here square. And directly above the stop here square is the resurrection square. These symbols are probably a little simple. So I can probably use some DOS extended characters to make that a little prettier. But for now, let's just go ahead and sit with this. Just now the program is waiting for me to hit a key, so I'll hit space, and that brings me back here. So let's go ahead and add to this. Let's just draw or write a quick function here that lets us select a square, and I think we might be done. Let's do a function that's going to let us select a square, and it's going to return the square that we're on. So we're going to do an int function. This needs to return an index basically in the array, and then select square is the name of my function. And what am I passing it? Well, I probably should pass it the board. So int star board, and then what player I am. So int player. Yeah, I use P for the other one. I'll call it player in this one. All right, so what am I going to do? I need to have a variable that's going to hang on to what square I'm looking at. So I'll do int square. We'll just initialize that to 0, the first square. And then we need to be able to read a key from the keyboard, so int key. I could print a message to the screen, and that's probably something I should add in a further version of the program to remind them that, hey, you're supposed to select a square right now. For right now, because it's a demo program, we'll just assume that we know what we're doing. So we're going to go ahead and draw the square that we're on. So we're going to draw a square, whatever square we're on, and we'll make it the active square. Now, when we draw a square, it's going to wipe out the entire square. So that means the player piece is gone as well. So we need to draw the player on square SQ, and we're pulling from the array board at that position. Because it could be a 0, right? So 0 is what we want to have in there. And that means we don't have to worry if we're, are we passing it a 1 or a 2? Nope. Just pass it whatever's in the array and let the function draw player figure out what I'm supposed to draw. All right, so let's actually go into a loop where we wait for a key. And let's do, to navigate, let's do plus and minus to go to the right and to the left. I could put in some other logic in here. This would be the right place to put it. If I want to do like up, down, left, right, we're going to make it very, very simple, and we'll just do a plus and a minus to go to the right, or to go up one square number and go down one square number. Or it's going to be Q to quit. So if we hit a Q, that means we want to quit the game. So let's do my do loop. So I need to do a do, and it's going to be until all right, so what do I need to have here at the end? So as long as some stuff. So what am I doing here in the it needs to be as long as the key is not Q, and as long as the key is not, let's say, let's make it a space if we want to select a piece. So there's my two conditions, as long as it's not a space to indicate that, yep, I'm selecting something. So in this do loop, let's go ahead and do a, we need to read the key from the keyboard, so we'll do get ch, oops, key equals get ch, and we'll go ahead and do a switch on the value of key. So what am I doing in there? All right, so what are the different things I can have? Well, let's say I've found a square that I want to move on. So that could be, I might have hit the space bar. So case space, well, if the space is empty, I probably shouldn't allow somebody to select an empty square. That'd be kind of dumb. So we'll say if that square, board square, is 0, then error, right? I probably should print out an error message at this point. For right now, just for testing purposes, we'll just assume that we print out an error. That's something we should add later. And I want to make sure I'm not hanging on to key being a space. So let's go ahead and reset key to something else. We'll make it, I don't know, X. And that's the end of my if. But what if it's not my piece? If board square is not the player that I'm looking at right now, which by the way is the same as it would be 0, but maybe I want to print a different error message. Then I want to print an error message. Here I'll just do a little comment to remind me to put in an error message. And then I should reset the key to be something else so it doesn't actually exit the loop. And that's not an if, that's an else if. And I think that's it. If it's not one of those, then the end of the loop will actually catch that. So I can do a break. I could just do an else return, but you know, it'll catch it at the end of the loop. And then let's do my plus and minus. So let's do a case if it was a plus. And so what do I want to do here? Probably should make the current square not be highlighted. So we'll draw our square with the square that we're on and make it not highlighted with a 0. And then was there a piece in there? Well, probably should draw the piece again. So draw a player on that square using the value from the array, board square. And then let's increment the I. What are we doing? I square. We'll increment the square, and then we should probably test that we didn't go beyond the boundaries. So if square is now set to 30, we don't want that to be 30, so we'll reset square back to 29. And I think that's all I need to do for that. So we'll do a break. Oh no, not a break yet. Before we do the break, we need to draw our new square. So draw a square, whatever the new square is, and we'll make it active. And then we need to put the player in it if there's a player in there. So draw player, square, board, square. There we go. And so now I've drawn my square, whatever my next, after hitting plus. And that's my break. And now I can do another one here. Case, what if I hit the minus key? So it's kind of the same thing that I did up there. So let me just go ahead and save myself some time. And we'll copy that and we'll paste it in here, except that instead of adding to the square number, we're going to do a minus minus. And that means if we are now at -1, that's less than, we need to set it back to 0. And that should be what I'm doing for the rest of the case statements. That should now be the end of my switch statements. And that should be what my function does to let me do a selection. Now, once I've exited the while loop, the do while loop, it can only exit the loop if it's Q or if it's a space. So I should do a test here. If the key is Q, I might put this up in the switch pace up above, but you know what? Let's just put it down here. So if it's a Q, we probably should return with some sort of an error message. We'll indicate that the person wants to quit. So we'll do a -1. Otherwise, we're going to return whatever the new square value is. And so that's what I'm doing there. And then back down to my main function. So now that I've added that, let's go ahead and put in select square. What was my calling syntax look like? Jump up here. The board and then the player. So we need to pass it the board and we need to pass it player 1. In an actual game, you would probably have this, you'd have this in some sort of a loop or runs between player 1 and player 2. So the player 1 can make a choice and then player 2 can make a choice. But right now, that's what we're going to do here. We're going to just do that. And we probably in a full game should make sure that as we select a square that we know it's a valid move. We'll save that one for later. Let's go ahead and do this now. So we'll go ahead and save and quit. And we'll go ahead and recompile wcl senet.c. And I don't see any errors or warnings except the one about the no new line. That's okay. So let's go ahead and run Senet. And now I've got my board has been drawn. And now I've got a highlighted square that has the, it's now in cyan. And so I can do the plus key. Hey, the plus key will move it to the right. When I get to the right-hand column, it's going to go in the backwards S position. So it goes down there. That moves backwards. And now it goes to the next row. And then it goes to the right. And you'll notice, by the way, as I go over each one of these squares that has a special marking in it, that's showing up as a bright cyan on a cyan background. So that way it kind of fades into the background a little bit, but you know it's there. And I can't go beyond, or I shouldn't be able to go beyond the last square. So if I hit plus a couple of times, yep, it's not letting me go back. And so I'll do minus, and I'll do the same thing going back. Now I can't hit space on a blank. It's me hitting space on a blank square. And this is player 1, so I shouldn't be able to hit space on B. Nope, because that's player 2. And so I back up one on A, and I should be able to select that one. So that's a space on there. And in theory, my loop should have exited. So if I hit any other key, because now I'm on the get CH, I'll just hit L. There we go, it ends. So it actually did work. So that is probably a good place to pause. What we've done now, we've now written enough of a game that you can actually see the board get displayed on the screen. We're able to select a square. And what's left after this is actually writing some code to throw some throwing sticks and to add the logic for moving pieces around, basically to determine if a particular move is valid or not. And we can cover that next week. But in the programming guide, if you're a patron of the C programming series, I'll put some programming assignments in there so you can actually get a jump start on that. So before I go, I just wanted to thank those of you who are my patrons on Patreon. You really do make this channel happen. Some of you are supporting me at a higher level, and I want to thank you here. Thank you very much. And visit our website at FreeDOS.org. Join us on Facebook, follow me on Twitter, and consider supporting me on Patreon. Thank you.